Hi, and welcome everyone to this new edition of the IVADO webinars. As announced, this webinar will be conducted in English. My name is Yvan Corriveau. I am Program Manager at IVADO. The main goal of this series of webinars is to present research initiatives and projects in the area of digital intelligence to inspire industrial members to team up with researchers in the identification and pursuit of new opportunities. Innovation is something we build, and working together can make it happen. For your convenience, the session will be recorded and made available to the YouTube channel of IVADO in the next few days. During the presentation, you are welcome to ask questions using the Q&A function at the bottom of your screen, and we will handle them at the end of the presentation. My colleague, Jean-François Bruno, Advisor, Industrial Partnership Research at IVADO, and associated at CIRELD, will present our guest speaker and introduce the topic for today. Jean-François?
Thank you, Yvan. Welcome, everybody. It is a great pleasure for me and an honor to present today's keynote speaker for this IVADO webinar. We have today a very large crowd, nearly 200 participants registered. So we want to thank you all, professionals, professors, students. Thank you all for your interest. We want to salute the participation of our IVADO industrial members, our academic partners, and our international partners. So special greetings from Canada to our friends and colleagues of the African Institute for Mathematical Sciences. AIMS is a Pan-African network of excellence that enables talented students to become innovators in Africa. Also, thanks to our colleagues from True North Marine, who are closely working with today's speaker to optimize ocean vessel routes. It is no longer a secret that in Quebec, we are now a leader in the domain of operations research. We have in our ranks some of the world's highest ranked researchers in operations research. These experts are passionate about real-life problems. They thrive to solve today's challenges as much as those prevailing for the future. Operations research improves the transportation of goods and people. It increases the intelligence and the resilience of the whole supply chain. It expands the opportunities for SMEs to become more competitive and to even level up the large multinational companies. Today, we have the chance to gather around one of the best researchers in the field of collaborative logistics. Mikael Rönnqvist completed his PhD at Linköping University, Sweden. He currently holds a Canada Research Chair in Operations Research and Natural Resources at Université Laval. His research interests are mainly focused on industrial and practical uses of analytics and operations research, especially in the forestry area. He enjoys tackling challenging industrial problems, and he was involved in the development of many industrial decision support systems that are based on optimization in the fields of logistics, transportation, scheduling, routing, production planning, cutting, and process control. He is also a member of the Canada-Quebec Research Network Forest to Customer, FORAC, and the Inter-University Research Center on Enterprise Networks, Logistics, and Transportation, the CIRELD. Now, let's welcome Mikael Rönnqvist.
Thank you very much. I'm going to just put my presentation here. So thank you very much for the introduction here. It's a pleasure to be here today to talk about some area I'm very passionate about. And in the presentation, there are a number of projects mentioned, and these are done together with a number of companies and a number of persons. So I would like to sort of acknowledge them as well here. We heard that there was a I'm sorry, there was a problem with my screen. Okay. So Jean-François did the introduction to me, and I gave a sort of short number of items here where I've been. So I noticed that I've been sort of mainly from, well, I am born in Sweden, and I've been working there mainly, both at university and the Forest Research Institute, but also been working in Norway, and now since the last 8 years at Université Laval. So my idea here is to talk about collaboration. So the outline is, I'll give you a short introduction, what is collaboration and some examples. I'll talk a bit about the theory, and then I will talk more about 2 case studies. One which is in forest transportation, and that a system being developed, so I can talk more about experiences from this one. And also talk about the new one in agriculture, which are a bit more new results, but new challenging problems. Also, depending on the time, I'll talk about some practical issue and games. And once we have finished this, I will send out a PDF version, so you have some references at the end if you want to go to more details, or just contact me. So when I talk about collaboration, it will be mainly about horizontal collaboration. So just some examples. So this is a very simple example. It's about transportation. So what you have here is in Heby there is a sawmill, so they need sawlogs. In Hallstavik there is a paper mill, they need pulp logs. So typically what you do with truck drivers is that they would get a transportation assignment where one might go go to Hallstavik with the pulp logs and go back and forward. So loading, unloading is 50% each. Another one would take the sawlogs to Heby, and you can see that you cannot get more than 50% loaded capacity in this case. But if they would work together, they share the loading, so they will do the same loop. This is called backhauling. Means that the sort of the proportion of unloaded part will go down. So the unloaded is the dotted line here. So that has a lot of emphasis on lowering the cost, reducing emissions of CO2. This is another example from Newfoundland. So in this case, there's a pulp and paper mill on the west side, and there are a number of sawmills, the yellow dots here. And because the harvesting is located all over the island, pulp logs go mainly to the pulp mill, and sawlogs, of course, to the other one. And because there's a lot of cross flows here, there's an interest to have some common terminals where they can do sorting, so they can really make the pulp logs go one way and the sawlogs the other one. So this is more collaboration in terms of capacity. Another example, this is from petroleum industry, is the left picture is the gas and oil field outside Norway. These are owned by different companies or different coalitions of companies. And to the right, you see the gas pipe system, and it's only one. So this is co-owned by all the operators. And of course, when the gas enters, you cannot know from which supplier it is. So they really need to work together in order to sort of share the cost and share the benefits and the management of the pipeline system. A lot of the work in collaborative logistics has been to reduce CO2 emissions, and often that goes hand in hand with when you look at transportation. If you can reduce transportation costs, you typically reduce the fuel consumptions and CO2 emissions as well. Just to give a short definition of collaboration, this is a picture I use. The person in the picture is my son. We both likes to go in the mountain. So when I talk about collaboration, it's an intentional cooperative action between 2 or more entities that exchange or share resources with the goal of making decisions or realizing activities that will generate shared advantages or losses. So what we need to do here is we need to look at the objectives of the participants. So my objective in this case might be to spend time with my son and get the nice area, you can see the good views in the mountain. And of course, for my son, it's similar. So we might have a joint objective. We need to agree on where we are going and where we start, where we end. So there are a number of activities that we share. Of course, we can also share some logistics equipment like tents and cooking material. So because we can do this collaboration, we don't need to take one tent or one cooking by ourselves. So we can share that. So that will lower the total weight. So that's beneficial. So the first step is we need to have some common objective. we need to look at the coalition. So in this case, is the two of us. We might want to see some other, but maybe they have another objective, so they didn't want to go in the same place. But once we have the coalition done, we can look at see how do we share the resources. So in this case, like I said, we can share. We have only one tent or one cooking thing, and then when we start to operate our collaboration, we need to manage it. So manage could be that suppose that the weather is very bad, we need to go to another point, but we need to agree on that. Or for example, if one of us get tired, typically I put more weight on my son, so we need to agree on this. So whenever you're managing your collaboration, you need to agree on things on the way. And of course, we need to share the benefit. In our case, it's more the sort of being together. But if you think about companies, then they need to also agree on how to share the benefits or share the costs if there are such costs, unexpected costs. So this is sort of the very basic on collaboration. So what I talked about was really this picture. So you need to have a common ground in your objectives and activities. You build your choice of partners, your coalition, and the level you want to collaborate, and then you manage the responsibilities and how to do the sharing. And when you look at collaboration, there are many types of collaboration. So on one hand, it could be very simple. It could be things like you're sending information through an email to another partner, but purely transactional relationship. Or it could be very strong collaboration where the two partners really do joint planning. They use the same type of track or capacity of terminals. They use the same software to do the planning, and they share very equally, I agree. So you have a range of those. Of course, depending on the maturity of the companies and type of activities, you will be sort of within those extremes. This is just a picture of forest value chain. I put it here just to showcase that when you look at an entire value chain, there are many opportunities for collaboration. So in this case, typically it's not just one value chain. There's one value chain for the sawmill industry, for the paper industry, for the energy, for the biorefinery. So you have collaboration across the chains. You have collaboration on the same level on the value chain. So like I said, I'm just going to focus on horizontal collaboration. I will not talk about vertical collaboration, where it could be one company organizing the planning of its own supply chain. So we're going to focus on the horizontal. So in order to do any collaboration, we need to have a lot of information. And typically what we do is we use this concept of a digital twin, where we have the reality, and then we collect information about the reality in forms of data, so we can build another model, the twin, where we have a digital representation. So we can do experiments, we can do planning, we can evaluate scenarios in the digital version, and then we can apply it in reality. So tools we need for that, well, typically in my case, I'm using different analytics tools. So depending on the problem we're focusing, it might be some more simple approaches. In this case, I'll talk about descriptive analytics. So it's quite easy to apply. And then it can be more and more advanced. So at the end is more prescriptive analytics that answer more the question, how can we make things happen? And typically here you will have more advanced optimization methods in order to support the planning activities. So we can use these analytics to support us in the planning and evaluation. Okay, so what about horizontal collaboration? So this is a very simple example. It's a red company and a blue company. So the red company has 2 mills and a number of supply areas. So each of those red and blue company, they have a balance in the supply and demand. So each of them can satisfy the demand of the mills by their supply. So in this case, you can see that there are a lot of lines crossing, which typically indicate that there is non-optimality here, because there are some supply which are closer to the red one, but goes to the blue one. Very important when we talk about horizontal collaboration is that when we're doing that type of collaboration, it's typically between companies that are competing at the same time. So we have a competition and collaboration at the same time. Now, in this case, if the two companies would say, well, let's share our resources. So we say that the supply is a common supply. Now, if I re-optimize again, I will have this type of assignment of the supply area. So some which are closer to the red or the blue will go there and vice versa. So of course you can see that the length of the lines decreases considerably here. And that typically relates to the cost and of course fuel consumption and emission. So the right one is a much better solution here. So there are some incentive for that. This is a real case. So what you have here is that two companies. One company have the blue and the black lines, so there are 2 mills behind there, and another one have the green and orange. Now on the sort of the west coast, you can see that it's not too bad because there's not too much interaction between the lines. But on the east coast, you see that the black and the orange lines, they cross over very often, which means that there is not a good use of the resources in that area. Now, if those two companies would agree to collaborate in the way that they do exchange some of the volumes, we would find that solution. So of course, now you can see that there are very few crossing lines, so indicating it's a much better solution. So in this case, it's very easy to implement because they just need to agree on the volume that they exchange. And then that company simply sends some volume to the other mill, but they can still be responsible for their own planning. Now, when we did that type of case study, typically the companies were very sensitive. So they always told us, you know, you cannot tell the other company how much we are saving. And both did the same thing because they were stressed that the other company will see that they will make more money, and then they will sort of the collaboration would fail because one would make more than the other one. So there are ways to deal with that. I'll be coming back to that. But that's another example for horizontal collaboration. This is a real case, a very recent case. To the left, you'll see the total cost for two companies working together. So the cost there is in Swedish crowns. So if you divide it by about 650, you would get the amount in Canadian dollar. Now, if you look at the blue line, you see that the proportion of exchange volume. So if I'm going from no exchange to the maximum I can change when I'm doing saving, I can save up to $6 million. So that's quite a bit. But you can also see that when I reach about 70% of the exchange, I pretty much covered most of the potential savings. On the right, you see that the total cost goes down by about 21%. So that's the integrated version. But when I look at the two companies separate, so to the left you have the total, but to the right you have the two companies. I call them just A and B here. So you can see that the company A, they save about 16%, but the company B, they save close to 30%. So meaning that the B company saves twice as much as the other one. So that might be unfair. So there needs to be some way that they can share that the benefit, but also to make sure that it's reasonable for both sides, for both companies. This is more a picture from Quebec, so I'm sure that there are many from Quebec here. So this is the mills for Resolute. So the green one are the sawmills and the brown one are the pulp and paper mills. So typically, because it's a very large area, what they do is they typically plan those activities by region. So within the region, they are not too bad to do the planning, but when they are working for the full province, they can work sort of in a horizontal collaboration between the regions. That this is more difficult, but if you have some support for that, it is possible to have that. Now, typically, one way they can collaborate on is the chips. So wood chips goes from sawmills to the pulp and paper mills. The savings are a few percentage for that when they're doing this regional collaboration. If they also add some of the other products, so in this case, it's the bark. So bark goes to the heating plants. So if you're doing collaboration between those two value chains, the savings goes up because in many cases you can do this type of backhauling. So then the savings goes up to 7 to 8%. This is also a forest transportation problem. The dots here are supply areas, and these are sent to a number of different mills. And there are many transport companies operating. So if one is responsible for their area, they can have some savings by optimizing. But if they would collaborate, they can do sharing of the transportation orders, and they can do more backhauling. So if you allow that, the savings can be up to between 8 and 16% by doing this collaborative logistics. And just to one more example here from Quebec. So this is a recycling plant in the middle between Montreal and Quebec in Trois-Rivières. And what they do is they receive recycled material from all over the province, but mainly from Montreal and Quebec. They process that and they produce products. Those products goes to different customers, and they go out to other customers like farms around Montreal or Quebec. Now, because it's only one plant, it's very hard to find a collaborative solution for that. However, when you look at the inbound and the outbound, and because the material can be transported by the same type of vehicle, the different transportation companies can sort of collaborate in the inbound and the outbound, creating much better, and again, these backhaul tours. So the savings in this case are very large because you can reduce the empty driving very, very much. So that's a bit of some examples. So I'll comment a bit on the theory. So when you have this collaboration, you typically talk about companies or players in a game, and the decision that the players need to do is to decide if they're going to stay out of any coalition, or if they will join some other players in a coalition, and if so, which one. So that the two main issues is really to build the coalition. So how many should be there and who, and then of course also given the coalition, how do we share the benefits or the cost. So this is a slightly larger case study. So in this case, there are 8 companies. They are all from southern Sweden, and they want to see if they can improve the transportation. So about 900 supply points, about 101 mills, many different assortments that needs to be met each of the mills. Now these 8 companies, they cover different areas, so that limits how they can collaborate with each other. So for example, in the picture here, you can see that company number 2 covers essentially all the area, which means that it can work with any of the others, because you want to have areas which cover each other. So company number 2 can work with all the others. But if you look at, for example, company number 1 and number 5, there's not a lot of collaboration potential between those because they don't cover the same area. However, 1 can work with 2 and 2 can work with 5. So they can form a coalition and working together and say. In this particular case, the interesting was to see, what is the potential if all 8 works together. So these 8 companies, not just do they cover different areas, they also have very different volumes. So the company number 2, which is the biggest one, has about 1/3 of the total volume. The second largest, number 5, has about 26% of the volume. And then it goes down, and the smallest, number 8, has less than 1%. So of course that creates a lot of different power when you're doing the negotiation to form coalitions. So these are some of the things. They don't cover the same area, and they have very different size. And in this case, these are monthly volumes. So overall in Sweden, they correspond to about 50% on an annual basis. And in this table, you have each of the companies. And in the column, which is called real, that is so we did some tests. So that's the real cost they paid out to the transporters for the given period. The column, which is called opt1, is when we go and say, okay, we can re-optimize for each of the companies. So we can do that. And then if you look at the bottom, you can see that there's a saving about 3.75%. And that's quite typical for this type of cases. The optimization can support up to 5%. The column opt2 is when we have backhauling included. And in this case, the savings goes up to about 5.3%. If you go to the column opt3, that's when they work as a joint company, so totally integrated. Then the savings goes up to about 12%. So about 8-9% more than if they don't collaborate. And the opt for is when they include backhauling as well. So when we did this case study, we were asking the companies, how would you share the benefit? And they said, oh, it's very easy. We simply look at the new cost. We look at the cost per volume unit, and then I simply pay the share of my volume. So I said, that's interesting. So when I computed the red numbers, that would be the improvements based on what they did before. So you can see that it's very different. So for example, company number 6, they save 19.9%, whereas number 5, which is the second largest, only save 0.2%. So of course, in terms of building a coalition, it would not be possible to sort of implement this one because there's too much variation of this one. So we had to find some other way to do the sharing. And if you go to the literature, there is a lot of different methodologies in this business. So I will not go to the details, but there are many. And more interesting is what's called the Shapley value. And that's something that Lloyd Shapley got the Nobel Prize for in 2012. So that's a way to better find the marginal values on different coalitions being formed. And if we apply that to the same case, you can see that the savings are more together, similar numbers. But still in Sweden, that these are very large variations, so companies want to have more similar. So we went back more to game theory. So we look at the coalitions, we look at the grand coalition, which is when all the companies are working together. We look at the cost for each of those coalitions. And then to do the sharing, we need to have what's called an efficient coalition, which is essentially that when we look at XJ, which is the cost of each of the companies, it needs to sum to the total cost. And then there are some restrictions like individual rationality, that no player should pay more than they do if they are by themselves. And the core conditions, which essentially says that for each coalition, we don't want the allocation cost to be above the cost of that specific coalition. So it's an incentive to make sure that there's no sub-coalition breaking out from the grand coalition. So in this case, when we have 8 companies, there are 255 coalitions. And we need to use optimization to find some of the coefficients. So one of the things we proposed was what's called the equal profit method. So essentially what we do is we measure the saving difference between 2 companies, and then in optimization model we minimize the deviation between the sharing the savings for any 2 companies, and then we add on the game theoretic constraints. So when we apply that, you can see in the right here, the equal profit method, that we could find a solution which are much more close together. So 8.8 for 7 of the companies and 6.7. So the reason why there's a 6.7 is that there is a sub-coalition of these 7, 2 to 8, which saves 8.8, because if they would be all together, it would save 8.7. And in this case, it's quite natural because the company number 1 is really in the northeast corner, and they knew about that. I will skip some of those here. So I have one first case, and it's really about the collaborative logistics by standardization. So these are all the transports done in Sweden over 1 year. So it's about 2 million loads. Each year there's about 200,000 new supply areas, and about 2,000 trucks running these operations. One of the main issues here is that you need to find the route or the distance, because forest companies pay trucking companies based on the distance they drive. So the black is the shortest, blue is the fastest, given the sort of speed limits. Orange is the one running on a better road quality. Green one is actually the one they prefer. But if you would ask forest companies, they typically tend to say that you should go on the shortest one because they pay less because of the pavement structure. Whereas transportation companies wants to take more deviations on the better roads and then get better paid. But the green one is something is agreed by all the participants. And of course, that's the green one is what we want to find for all the 2 million transports done every year. So they don't need to comment and negotiate for each individual. So of course, when you're a truck driver, there's a number of objectives you need to balance. So it's sort of fuel consumption, it's your hilliness, which increase your fuel consumptions, it's the stress to running if you need to brake and accelerate all the time. It's also, of course, about the distance. So in this particular picture, you can go the shortest, which is straight through there, but it's more hilly. Or you can go around, which is more curves. Or you can go the left one, which is really sort of a high-quality European highway structure. Or you can take a shortcut through the village. But then you pass schools, and you don't want to do that. So, of course, it's always a balance. But what the industry wanted is a tool to find the best practice. So what we did is we developed a system, and in that system, of course, you realize that there are many. It's a multi-objective problem, and the objectives they have here is things like I mentioned, that the distance, safety, stress, fuel consumption. But the things that are actually measured and for which you have data are what's on the right. So these are things which are in a sort of national road database, similar here in Quebec. The problem is that you need to find 106 weights of those road features that match the objectives. And anyone doing multi-objective knows that even when you have two, it's complicated. So the first trials were very unsuccessful. But then we turned to the industry and said, what is the best practice? So we collected really detailed information about what we call key routes or the best practice. And then we turned around the problem and said, okay, if I run a normal minimum route problem, what would be the coefficient such that if I run it for those 1,500 key routes, I will get that as an optimal solution. So this is really an inverse optimization problem. I want to find the coefficients that gives me those as optimal solutions. Of course, this is just a subset, but once I found those weights, I can apply them for all the 2 millions per year, which are the real one. We implemented, but there are some issues. So for example, when you run through cities, we run straight through, but they want to go around in the red one here. We find information about that, then we can set on weights. So now we route like that. There are questions also on the hilliness. So they want to reduce fuel consumption. So they want to avoid hilly routes. We managed to find a way to characterize these hilliness. So we put that into the system. Same thing for curvature, because curvature is you need to brake in the curve and then you need to accelerate. So it's stressful and it increases the fuel consumption. So we could add that as well. So the system now, when we started it was in 2009, and now it's I would say something like 80% of all the transports are using the system directly. So some companies, they didn't want to join in the beginning because they said we needed things like the curvature. But now when it's there, pretty much most of the big companies are there. So about 100 companies are using it, the system online now. And it's very sort of simple. For these companies, when they have a transportation order, they send the assignment to the transporter through the system. And the truck driver knows the route and the distance, so he knows how much is going to be paid. He can use that information to plan the day or the week. He do the routing, it's measured. That information is sent directly to the force companies who do the payment. So it's a very sort of closed loop. There's no need to do any negotiations. If there are problems, there are deviation reports that sort of supports our the development of the system. This is just the number of calls per month. So on a typical month is about 400,000 calls. So the organization who runs this, they have 3 servers all over Sweden to do this sort of, because you need solutions within a second. Even though the purpose was not to save money on this, administration went down, so there was a number of savings there. We could route better routes, so fuel consumption went down. And also, but one of the big contribution here is really about the collaborative logistics. Because when two companies use the same methodology to compute distances, collaboration becomes easier. So that's a big potential, and many companies are doing that. My second case study is more about in the agriculture. So it's about farmlands. So here is an aerial view it's an area in southern Sweden. So you see all the farmlands. In this kind, in the orange, are all the roads in the area. So when you're a farmer, of course, you have your logistics center at your farm, and then you have your tractors and different machines. You use the roads to go out to your parcels. You do the operations, and then of course you go back. So that depending on the distance from your center to your parcel, there is a cost, and of course a fuel consumption, in this case with the tractor's diesel. And so that's something that they want to lower. These are the farm centers. So these are our farms here in this area. These are all the parcels in the area. And of course, some of those farmlands, they tend to be close, of course, but they're also because of a fragmented structure that evolved over the years. So in this case, you can see that there's one farm. The parcels are very scattered. So there's one really in the west, and of course that increases the cost for running with the tractors. So of course, in this case, the purpose is, can we find some coalitions where they can swap parcels with each other? So this is a fairly two big farms, but you can see here, it's very easy to see. So if you see my, it doesn't work here, but you can see that there are some blue areas to the east here. Of course, they could be swapped to the yellow one because the yellow farmland is more in that direction. And of course, the yellow one at the west side should really be blue one. Yeah. So by doing an exchange, they can save a lot of the distance. But of course, in our case, there are not just two, there are 3 and then 4 and 5 and 6. There are many sort of farms here. So in the project, we set up a number of models to look at the potential for collaboration. So in one of the cases, we said that, okay, all farms can work together. Now, when all works together, it could be that some actually lose. And then the second one is to make sure that no one lose. And then, because of more practical concerns, we said that, okay, we have one case when we limit the collaboration to 2 and then to 3. But the objective is also different. So one objective is to look at the potential. So what we aim to do is to bring parcels close together to the farm centers for potential use. And the other one, I call it minimize SAK, is really to minimize the cost, because if we look at the different parcels, they have different quality of the soil. So some are better for some crops. So if we keep the type of crop types as well, and we say that we want to have the same crop type because they are the one best for that type of soil, then we can minimize the costs for the operations instead. So that's how we set that up. We have some case studies.
5 minutes.
And some of the costing. Okay, thank you.
Yep.
So in this case, we have many different steps for the operations, and so it's quite detailed cost curves. So in our case, we can have 6 crop classes depending on the type of crops. So I'm sorry about the Swedish here, but the one of the top one is potatoes. You can see that, and then there's sort of barley and wheat and other things here. But quite different cost structure for some of the crop type because also of the soil quality. When we start to look at the optimization models, I will not go into any details. Anyone interested, just contact me. By the way, when we look at the more simple case, when we say that everybody can collaborate, which turns out to be the easiest case, it becomes very large. So for one case we had, which is in a region called Linköping, we had 21,512 parcels on 1,062 farms. So very large problems. And the number of constraints and the number of variables for the first are not too large, but when we go to the other cases, we need to add more variables and more constraints, and especially constraints. It becomes too large, so not possible to solve. So we did some pre-processing where we looked at sort of how far can we do the swapping of parcels, because in practice they would not go too far. And by doing that, we can reduce both variables and constraints. And when we go to the study areas, we select the number of areas. So these are the one red indicated there. So you can see that number of farms goes from quite low in the northern one to about 164 to the biggest one, which is the Gotland, the island to the east. 1,431. And the number of parcels goes from about a few thousand up to more than 32,000 parcels. So it's a very large problem. Some of those are very special. So one case is really agricultural land. Picture to the right are really following two rivers up in the northern part. So you can see that, of course, collaboration across the river is very difficult. Some, in this case, it's really in the forest area. So it's a bit further apart, the parcels. The left one is really in a region where you have a lot of lakes, so many bridges that limits collaboration. Right one is one of the islands, so that's much easier because there's no boundary impact. In Linköping, there's very close to a city, so you need to take that into account. And the last one is one of the islands. So again, large island, many parcels and many farms. These are lots of numbers. I will not go to all, but this is in Linköping. So like I mentioned, more than 1,000 farms, 21,000 parcels. Average distance from farm center to parcel is about 3.5 kilometers. When we run the optimization, you can see these are the size, so quite large size to solve because all are binary variables. When we look at the improvements, you can see that it's a lot of improvement. So the easiest case, when I'm most limited, can work no more than 2, still 50% savings. When all can work together, it's more than 50% in this case. So huge potential for savings. If I go to all the cases, the trend is very similar. There are very large savings in all the cases. So it's a big potential. We then went to a few farmers to get more detailed information to see how they could set up this type of collaboration. So here there are actually 4 farmers indicated by the different colors. And we run the optimization saying that, okay, what is the potential for each of those farms? So we essentially set the priority higher for each of those to see how they could swap not only with those 4, but also with the other one around them. And of course, you can see in this picture that they can really compress the parcels around the farm, the logistics farm. If I look at the specific case, this is the current case, so quite sparse. But if they could really select the best one, they would have that structure. So 72% lower cost in diesel consumption. Of course, some of the neighbors here might not save them the most, but this would be the potential if that farm would have some kind of tool to find solutions. So here is a more summary of this one. So like I said again, you need a lot of information about the parcels, the farms, the distances, but that's available. Large savings, and if we look at sort of for the entire country, so the second last point here is about 1.2 million parcels in total. So the total savings is about 117 million Canadian, and that's for every year. So again, this is a very interesting something we're working on, and we are now looking at how to develop tools for supporting the farms in this. I have just a few minutes, but I want to talk about some practical issues, because when you look at this collaboration, you will see that there are many articles that show big potential, but then in practice, many of those they are not they're not put through, or they by some reasons you cannot see they work in for a long time. So what we did is we did some survey to find out what are the reasons. So we found in this case 62 articles dealing with this type of issues, the collaboration and issues why it was not operating. And we developed a taxonomy for these practical issues, one more associated with the design, the coalitions, one with the planning operations, one with the business in terms of collusion and sensitive information sharing, and one more for the behavior, for trust and culture and sensitive things. So the purpose being that if we have cases, we can look at this and see, what are the potential pitfalls, and knowing them, we can put that into the negotiations so we can avoid those happening along the process. I will skip this one. So I can take this one. So here, this is the case with the 8 companies again. So some of the restrictions we have are for sure antitrust laws, no sharing information. Sometimes they don't want the financial transaction because they wanted the solution embedded directly in the plan. In some cases, they wanted more responsibility for their own meals, and really the cost sharing embedded directly into the optimization, so you don't need to do the sharing afterwards. And of course, long-term relation, the trust issue here. So many of those things are very important for us to be working in practice. I think just very shortly, so this is an illustration of how the government and local governments can impact how you can do collaboration. So this is a case, it was a big storm, now it's quite some time ago, but the wind fell of the forest was 70 million cubic meters. As in a comparison, in Quebec, the annual harvesting is 30 million. So huge volumes. Big sort of problem with the logistics, need of many sort of support teams from many countries, and capacity, transportation, and harvesting. Just a very few. These are very localized, damaged, very dangerous, slow operations. Supply and demand used to be balanced, not anymore. So big challenges in how to sort of redistribute the logistics balance. New transportation modes, trains, vessels, huge need to store, because you need to bring out all the trees within a certain time, because you cannot lie and rotten and get insects. Some terminals extremely large, so you need collaborative logistics for that. Some storing in lakes, you need special permission for that. So just to showcase that the government could really impact here. So more federal and local government, they changed the rules of the game. So they changed the max capacity of trucks by 5 tons. That alone increased transportation capacity by 12.5%. They delayed some of the rules for when you needed to have storage in the forest and not. They changed the rules for having international drivers and for trucks and harvesters. They changed the rules so the environmental impact analysis were much faster for example, when you are storing the lakes. They agreed on some minimum value for the logs, not to push down the value to very low value, so many would go bankrupt. So that enables the companies to, even though they still competed and they work a lot by themselves, it enabled them to have some collaborative logistics in terms of terminals and capacity and similar things. So I think I'm running out of time now, but at the FORAC Research Consortium, we developed a number of games because some of these concepts are very difficult. So we have games for collaborative, horizontal collaboration, vertical collaboration, things when you collaborate and you compete at the same time, and some more project-based. So those interested can go to some of those articles. So just to conclude, so me, I really enjoy working in this area. So and particularly in this horizontal collaboration, there are many game theoretical models that are developed for collaboration and configuration, sharing, and various analysis. Like I mentioned, there are many obstacles to overcome. So in order for this to work in practice, but there are sort of tools and processes to support that. We have these educational tools to support the understanding, which can be tried both on students and professionals. And I do believe that there are many rewarding challenges for the future in this domain. So with that, I will stop. So take any questions.
Okay, thank you, Professor Rönnqvist. Now my colleague Fabien Perrineau, Advisor Industrial and Partnership Research, and I will facilitate the question period. We will go through the list of questions proposed so far and submit them on your behalf to Professor Rönnqvist. We might not have time to do too many, but at least we'll do a few and we'll take it from there. So maybe if Fabien, you want to take the first one?
Yes, of course. Thank you, Ivan, and thank you, Mikael, for the really interesting presentation. So we had a lot of questions. So first one, okay, so it seems obvious that to work in collaboration, but somehow it's not always done. So it seems that the main issue is always being afraid to share information that could potentially be used against us. So is the negotiation and discussion always the way to go, or to be transparent and upfront?
I think that there are different ways to do that. I know that in some of the cases we have, some of the information they share are not very sensitive. Sometimes it's more about the location of supply areas and some of the prices. One way to do it, of course, if you trust each other, some information can be shared. Another way is to use a third-party logistics provider. So what you do is you provide all the information, including the sensitive one, to this third-party logistics provider. And then they do the joint planning and then redistribute the plans to the different companies. So in that way, there's no need to share the sensitive, but you can still use it for the joint planning. So that's something we've been doing both through the third-party logistics providers. But some of the tools today now, what they do is they allow you to put in your information, and you can only visualize that. It's only the optimization creation that sees the sensitive information. And then you can use a direct platform for that. So that's the more it's not that many, but the first one with third-party logistics provider is quite a common way to deal with that type of problem.
Yeah. In a similar fashion, I guess it's maybe just a different variation, but would that be an optimal solution to outsource transportation at all to a single company specialized in transportation and let the other company do their core business?
Yeah, it's for sure that, I mean, that would depend on your agreement with the third-party logistics provider. So of course, for sure that if the third-party logistics provider are the expert in the domain, and they can pull together transportation orders from multiple companies who are not working together, of course that's an easy way to sort of get efficient. An efficient transportation. But if you want to work more close to another company, well, of course, then probably the most efficient one is to work directly with that company without going through a third-party logistics provider. So I will say it really depends on the type of application, because like in my area in the forest, most of the forest companies, they are also very good in the transportation planning, and they have capacities for that. But of course, if you're a company who don't have the transportation capacity, then of course it might be better to go through more third-party logistics provider, who are the one who pull together the different companies, and they can do the horizontal collaboration sort of internally.
Okay, thank you.
Okay, another question. So it looks like this collaboration approach can be really beneficial for the environment. So in this perspective, have you considered, using the Agenda 2030 of the United Nations to show the impact of the case studies?
I think that in our case, so many of the companies, if I go back a number of years, they really wanted to do the collaboration because to lower their cost. But I would say that many of the companies today, they want to do the collaboration because of being able to show that they can reduce their CO2 sort of footprint. So I mean, in this business with the transportation, you are typically lucky that reduction of fuel, reduction of emissions goes hand in hand with the reduction of cost. But I would say that many of the companies and some of the forest companies I know, once they do this collaborative, they put that also in the annual report as a proof that they are following the the aims to be more environmental friendly, and they really put it in their annual reports as well. So that's another motivation now for sure.
Okay, and maybe a last one, Mikael, in some similar vein. It feels like the commercial benefit is not high enough to convince companies to collaborate. Is collaboration possible without government regulation? In other words, would government subsidies help make it happen? Or it's
I think that in some areas you need the government to put in some incentives. I do believe that. So I'll take a very local example. So in Quebec, to build, there's some ideas to build a biodiesel refinery in Quebec. That means that companies need to work together. But of course, at the moment, the price for the diesel is simply too low to be competitive. But of course, if the government changes the rules that some parts need to be biodiesel. That totally changed the structure. But I would say that in the other cases I have, those are motivated they're not enabled through the government. They are really enabled through the companies themselves. So I would say that most of the collaborative logistics cases I've been working on can be motivated before you have the government interfering. But some other might be enabled by the government. So I think they're both of them. I think that the former are the bigger.
That's good. Thank you. So that's unfortunately all the time we have for questions. So maybe there could be some questions done offline. So on behalf of IVADO, I would like to thank you, Professor Rönnqvist, for this very stimulating conference. I'm personally impressed by the fact that you address in a pragmatic way a complex logistic problem, for one. You can manage to have a positive impact on the CO2 reduction, for two. You can find ways to generate economical savings, for three. And on top of that, what is kind of fascinating is you have explored like creative avenues to share the created value among participants. It doesn't seem to be a resolved problem yet, at least there's some avenues. And what I like to say is when there's something to be shared, there might be a solution. When there's nothing to be shared, there's no solution. So congratulations for all that work. We have a few pieces of communication to mention you for the next venues. Okay, so the first one is that IVADO has organized some machine learning applied finance to insurance. It's an online workshop going from June 30th to September 3rd, twice a week. You can go on the site, you have the address there, ivado.ca atelier FinML, have all the details. It's a very interesting set of like workshops. That's one thing we would like you to, or encourage you to explore. Also, what we've done over the last few weeks, we've teamed up with SEMLA, who used to have like a yearly conference, and this year they had to do it like online, so we've worked together on that. And they have arranged like a series of 5, there will probably be 6 prestigious conferences going on. It's called the SEMLA, the Software Engineering for Machine Learning Application. It's attached to the Polytechnic. There are like very prestigious people who's like a legend, if you want. And the first one is tomorrow at lunchtime. Diego Oppenheimer, CEO and co-founder of Algorithma. Those conferences are free. And again, on the slide, you have the details if you want to register. And you can go directly on the IVADO site if you want to do it directly there. So that's it for us now. We would like to thank you for attending this, this webinar. This webinar has been so far our biggest one. We have like well over 100 people attending from different countries, different universities, different continents, and we're very happy about it. We would like again to thank Michael for all the great work he was able to share with us today, and all the people that were involved in arranging that. Thanks and have a good day.